HVAC blower motor and circuit control. The automotive HVAC blower motor is in charge of pushing cabin air past the evaporator, which in turn cools it. The colder evaporator doesn't really cool the air, but takes heat away from it. As important as the blower motor is, the circuitry that controls it is even more important. In the past, an airstream resistor was used to give the blower motor its three speeds, or low, medium, and high. However, nowadays it is all done electronically, and the electronic controls vary in many different ways. The original resistor-based blower motor control was a simple resistor winding arrangement, and was cooled by the air conditioning airstream. This simple arrangement served its purpose well, but had no intelligence whatsoever. So, what do we mean by intelligence? Modern automotive climate control systems are completely integrated to the engine operation. By this we mean that the vehicle's ECM or engine control module takes into account the blower motor operation in conjunction with the engine and transmission. Other systems may also play a role. So, in a modern automotive climate control system, the air conditioning computer operates the blower motor according to engine and driver demands. Here's how it works. The ECM receives inputs from the driver, and then controls the engine as needed. This data is broadcast on the vehicle network, and engine speed and load are used by the climate control system computer. Blower motor speed varies according to engine speed, and various other inputs. The blower speed controller is used with automatic temperature control systems. The speed controller converts a baseline signal received from the electronic control assembly into high current, variable ground feed to the blower motor. In the vast majority of cases, the blower motor is ground controlled. This means that the 12-volt power is held steady via a blower relay, and the ground is varied to attain variable speed. The blower fan speed is therefore infinitely variable. The actual control is done by regulating the transistor or power chip base signal, which in turn regulates the high current blower ground feed. Some blower motors may draw as high as 10 amps of current. The blower speed controller is often located in the evaporator case, upstream of the evaporator core. Automatic climate control systems often use multiple fuse circuits to separate higher from lower current circuits. It is normal to have one or more fuses that protect various circuits. A separate fuse normally protects the blower motor control circuit itself. Issues such as excessive current draw, one of more speed settings inoperative, no operation at all, or erratic speed are symptoms that require an intersystem knowledge of the climate control. Diagnosing the blower motor will be discussed later in this series.